to 6.1 with respect to y. So far all of our equations have been in the nice pretty y equals or f of x equals. In other words, we've been finding the area with respect to the x-axis. When I'm looking at that, this has been the x value, f of x, g of x, okay? Well, not all equations are in that form. Some of our equations have been implicit. Think about all the implicit differentiation we've done in the past. Well, those kind of functions still happen. So, we may have them in terms of x, but we may have them in terms of y. Never fear, we can do it both ways. Well, now when we look at this, this is what we did yesterday. We had it in terms of x, so of course everything was in line with the x's. All of these guys were x values. Okay, so that was an x value, this was an x value. These were all x's. Okay, so very nice. Well, now we want to think about what happens if it's in terms of y. That means everything in here has to be y's. Well, we want to make sure that that area is positive. So the one that has the bigger x value, that's the function that's going to be on the right. So that's why we have right minus left, because this has the higher x value. Okay, so this has a bigger x value, just like the top has the bigger y value. That ensures that our area is going to be positive. Okay? Well, everything's got to be in terms of y, so we have our y1, our y2, and just like with the x's, smaller number on the bottom, bigger number on the top. So that's going to give us this area right in here with respect to y. So let's see when we're going to need to do this. Okay, so when do I find the area with respect to the y-axis? It's not comfortable for us to do this with respect to y. The biggest thing, or the biggest reason why, is because we have to have our equations in x equals, and unfortunately our calculator doesn't graph x equals, it graphs y equals. So a lot of the times we're on our own for graphing. If they are asking us to find the area with respect to y, it's going to be easier for us to do that. It's going to be easy for us to graph that without a calculator, so don't panic. Please do not panic. So the two reasons why we would find the area with respect to the y-axis, it's when the equations are already in the form x equals. Or maybe it's difficult to solve for y or impossible to solve for y. Something like this. Okay, we can't solve that one for y. So we would want to find the area with respect to y. The second reason we might want to do it with respect to y is that the area is simply less complicated. Okay, so if it's going to be easier, let's do it. If it's going to be the only way, well, then I guess we've got to do it. So let's look at our first example. X equals the cosine of y. Now in this example, we could actually solve for y, but then we would have inverse cosine. Ugh. We're not so good at the inverses. Some of us aren't so good at the cosines. So we're going to keep it as it is, and we are going to integrate with respect to y. Now notice we've got our two functions. We've got x equals the cosine of y, which should be a nice smooth curve. We've got x equals 1/2, which is this dotted line here. It's a vertical line. So our cosine line is the guy in green. So let me gussy that up a little bit. And this is our dotted line in red. Now they've given me an interval from pi over 3 to 7 pi over 3. So I just plugged in these values. Okay, so these are my y values. Well, when I do the cosine of pi over 3, that was 1/2. The cosine of pi over 2, that was 0. The cosine of pi was -1. So I actually chose these y values according to what's going to be a nice pretty 1, what's going to be a 1/2, so I had to go with the 60s, and then what would be at 0 and -1. So I chose these values for my y specifically for this graphing example. Okay, because we had the 1/2, I know that's going to be the pi over 3 related angles. Where I equal 0, that's going to be my pi over 2 angles. Where I'm equal to positive 1 is going to be my 0, 2 pi, 4 pi, 6 pi. I'm going to equal negative 1 at the odd pi's. So I get two distinct areas. I get this area here, and then this area here. So I will have to split this up into two separate areas. So this first area, 1 here, I'm just going to call this my first area. This is going to be my second area down here. So area 1, I am going to go from, look at your y values, I'm going from 5 pi over 3 to 7 pi over 3. And then I'm looking at which function is to the right. So the function that's to the right is that cosine. The function that's on the left is the 1/2. We are in terms of y, so it has to be dy. So just check your integral. Is it all in terms of y? Are these limits the y coordinate? Do you have y in your integral? Do you have a dy? Okay, so you want to make sure that you have those. Now, area 2, we are going from pi over 3 to 5 pi over 3. This time, it's the 1/2 that comes first and the cosine that comes second. I still have to have that dy. Okay. Now, you can put this in your calculator just like you've always done. It doesn't matter what that variable is, as long as it's all consistent in there, and it's going to integrate that just fine. So 0.684853, and the other one was 3.8264459. So don't forget to find that total area, which is the addition of them both, their sum, and don't forget to now round to 3 decimal places. Don't round up here, don't round here, only round here, okay? So this one we could have solved for y, but geez, it would have been difficult. Let's look at another example. Okay, when I'm looking at this or x equals y squared plus 1, once again, I can solve that for y, not a problem. I will get a plus minus, so I'll have 2 separate functions. And then my line, not a problem to solve that one. Okay, but I'm going to go ahead and graph it and see what I end up with. Well, this x equals y squared plus 1, that is going to be a parabola pointing to the right at x equals 1. And then I've got that line that's going to have a y-intersect. Okay, and you always want to look at the line y equals, so this is your y-intercept. It's going to come up through like this. Choo-choo. All right. So when I'm looking at the area that is shaded in between those, I'm looking at this guy right here. Oh, I know you look at my artwork and you think, gosh, if only I were as talented. Oh, remember I set the bar low for you and your self-esteem. All right, anyway, old joke. Find the area between these two. Now, if I wanted to do this with respect to x, I could do that. But when I'm looking at this with respect to x, look at what happens. My top function and my bottom function aren't consistent throughout the whole thing. Here I would have that positive square root. Here I would have that negative square root. On this side I have the positive square root, and then I have that line. So I would have to do 2 separate areas if I were to solve this and put this in terms of x. Plus I'd have to solve this equation for y. Ugh. So let's look at it the other way. So if I'm looking at this in terms of y, that means I'm looking at it this direction. Okay? So if I'm looking over here, my top or my right function is the line. The bottom function is my parabola. Well, if I look at it over here, same thing, line, parabola. Same thing all the way through. So if I do this with respect to y, I've got one area to deal with. Not only do I have one area, but look at the equation I have to solve for x. This one's already solved for x. This one, I just add 3. And it's already solved for x. Now I do need to find my points of intersection, so I need to find this y value and I need to find this y value. And you can do it the same way you did the other ones. You can set them equal. Both of those equal x, so if you just set them equal to each other, and then you can simplify, we get y squared minus y minus 2, and that does factor. Y minus 2, y plus 1. So I know my points of intersection are at 2 and negative 1 and 2. So I'm ready to write my area. I'm going from negative 1 to 2. The function that's on the right is my line, so that's y plus 3, minus my function that's on the left, which is my parabola. If you don't want to use parentheses, you don't have to, but you're going to have to distribute that negative. Now, before you finish, make sure, do I have nothing but y's? If I look at my integral and I see some y's and some x's, oops, I didn't solve my equations properly. Making sure these are my y coordinates of those points of intersection. It's all about the y at this moment in time. So when I put that in my calculator, that's going to give me 4.5. That's my area. Same thing you need to look for. If this turns out to be a negative area, then that means you've got them in the wrong order. You need to switch your integral and see if that changes the problem. Okay? All right, so let's look at another. Okay? When I'm looking at this equation, now I can't use my calculator because I can't solve it for y, but please don't panic. You know that if one of them is a square and the other is not, it's a parabola. Negative is going to open to the left. Well, go ahead and set this equal to 0 to find those y-intercepts. Okay, you're just going to factor out a y. That gives you y plus, let's factor out a negative y. So that's going to be positive y minus 2. So we've got those y-intercepts at 0 and 2. So 0, 1, 2. I already know I point to the left. Whoa, that's pretty. And then I've got my square root. Let's do that in a different color. Okay, so the area we're looking for is that little sliver right in here. So I just need to find out where those two equations are going to intersect each other. I also need to make sure that I take this equation and solve it for x. In order to solve it for x, I'm going to have to square both sides. Okay. Now make sure you're graphing the square root, not the square. This function I'm only using, okay, a part of it. Okay, so don't graph x equals y squared because you are going to be sad from your results. All right, so if I set those equal to each other, y squared equals negative y squared plus 2y, you're going to get those both to the same side. You're going to factor out a 2y, which is going to give you y minus 1. Okay, so those two functions intersect each other at 0 and positive 1. So that's at 1 and this is at 0. So if you don't get to use your calculator, you may be finding lots of points of intersection. It's just algebra. It won't hurt a bit. So we go from 0 to 1. Now the function that's on the right is this y squared piece. Oh, nope, sorry. It's these parabola. So negative y squared plus 2y. And then we're subtracting that square root, which we had to solve for x, so that's minus y squared. If you're using your calculator, use your calculator. If you're solving it by hand, then please make sure that you do simplify that. You should end up with 1/3. All right, this final one, this one's for you. I'd like you to try that, and we will check our answers when we get